friends, welcome back to our channel. So in today's session we'll discuss about one more topic in our data structures using Python. So that is a circular linked list. Circular linked list. So this is similar to our single linked list. So here also we are going to use the single linked list. So single linked list. So everything is common, but only one difference is, so last node will have address of first node. First node. That means a collection of nodes connected in circular fashion. Circular fashion. So circular fashion means the last node will be connected to the first node. For example, if you take 10 and the second node is 20, 30, 40. So this is a circular. Okay. So 10, the address of this 10 will be holding of next node, right? So see, simply we can say here the node will be having two parts. One is a data. I'll take 10. I'll take another node with a value 20. I'll take another node with a value of 30. So the address of this one is 1000, it is 2000, and it's 3000. Right? Now see, the address of next node will be stored in the present, right? So 10 and this part, so this part is a next part, right? So which holds the address of next node. So here the address of next node is 2000, so 2000 will be stored here. So there will be a connection, right? There will be a connection. Now here 20, then in this node the next will be having the address of the next node, right? So that means it will hold 3000, and so the connection will be established. Now 30, and here again we will be having the second part, that is next. Usually if you are using the single linked list, this will become null. Okay, usually the last node will hold the null in that particular address field, but here this particular last node will be pointing towards the first node. So last node will have the address of first node. So what is the address of first node? 1000. So this is a 1000. So immediately a link will be established from here to here. So the nodes are connected in a circular fashion, right? So this is called as a circular linked list, right? So I'll tell you the theoretical part here, and I will execute the program in our in the further time, right? See, here mainly we are going to use two different classes. Okay, we are implementing this data structures concept in Python, so we are going to use them object oriented programming. That means with the help of classes and objects we are going to implement this circular linked list, similar to our single linked list and double linked list. So here we use a class node. So this is for each and every node. So a node will be having two parts. One is the data and another one is the next. So where we have to initialize? So all the variables should be initialized in a constructor in the object oriented concept, right? So before watching this one, so just make sure you are aware about the object oriented programming in the Python, right? So already we have recorded the sessions, so just go through that so that this will be very easy for you. So whatever the variables inside the class should be initialized with the help of constructor. So here the constructor will be in format $_init $_, and for every function including the constructor, the first parameter will be the self, right? And the data, we need to give the input for the data, right? We need to give the input here. in our example we have seen some 10, 20, 30. So 10 is the first node data, 20 is the second node data, 30 is the third node data. So we have to pass the data itself, right? So what is this one? So self dot data is equal to data. So this variable will be coming to this self dot data, right? Class variables. Similarly, what is the second part? Self dot next. Self dot next is equal to, initially let us take it as a none. That means a null value. Similar to our null value, here we will call it as a none. Initially, okay, this is an initial. So whenever we are creating a node, the node will be, so after executing this code, a node will be created. And if you pass some data as some 100, so 100 will be stored here, and here it will be none. Okay, immediately after completion of this code, after executing this code, that means this 4 lines of code. So 100, if you pass the data as 100, 100 will be here and none will be here. And this is the next part, this is the data part, and let it be n1. n1 is a node, right? So if you want to access 100, it will be n1 dot data, and if you want to access this one, n1 dot next, right? Yes. Next, after that we need to create one more class for the circular linked list. So in the circular linked list we are having a different operations. We can use different operations, right? So that means we can insert the data, we can delete the data, okay, we can display the data. So all these are the operations done on the circular linked list. So in order to implement all these operations, that means insert, delete, display, searching, etc., etc. So we can create a one more class here, right? So I will create here class some circular linked list, right? Circular linked list. So all the operations should be performed in the form of functions here, right? So class, inside the class, again, first of all, take the constructor, because here we need to initialize two things. One is a head and tail, because in order to process the data from starting node to ending node, we need to give the labels like a head and tail. So head points at the first node and tail points towards the last node in the circular linked list. So here usually the head and tail will be same. Okay, head and tail will be same. But with in order to avoid the confusion, we will simply go with the head and tail. So without the tail also we can implement that, right? But without any confusion, so in order to avoid the confusion, just we'll go with the head and tail. It would be very simple, right? Now initialize the thing using the constructor init, and here self, and see self dot head is equal to none. So initially the head is not pointing towards any other node. Similarly, self dot tail is equal to none. So here the tail is also not pointing towards any node, because it is an empty circular linked list. Okay, this is a constructor, right? So empty circular linked list. If you insert any node, we need to change the head and tail. So if you insert 10, and this will be a none, so this will be head and tail. And similarly, if you insert one more thing, 20, so here we need to replace this one with the address of second node 2000, okay, and tail, head will be remain same because this is the first element. Tail will be moved to here. So this is the second element. And what we have done, so last node will have the address of first node. So what is the address of first node here? 1000. So 1000 should be placed here. 1000 should be placed here, right? So like that, some head and tail should be used in order to do the processing, right? So how can we display the data? Okay, how can we display? So first, in this session, we'll see the two things. One is create and display. How to create a linked list and how to display the nodes of a linked list. So this is the creation. So we have created one node, class for one node, and one class for circular linked list. Now display. How to display the data? See. So I'll write the complete program. I'll execute the complete program for this create and display. So without using any special methods like insertion, okay, insertion at the beginning or ending. I'm not using any sort of functions. So directly we'll write a few lines of code to insert the data and to display the data. Mainly we'll see for display function. So display function. So in this display function, what we have to do? So we have to start from head to tail. Okay, we need to start displaying the data from head to tail. So in order to display the data, what we have to do? So print. Okay, so here head should not be moved. Okay, head should not be moved. I'll take one example so that you can observe. See, I'll take 3 nodes. I'll take 3 nodes. So one is 10, 20, 30, right? So here it is 1000, 2000, 3000, and it holds the address of the next one. So 2000, it holds the address of next one, that is this one, and it holds the address of the first node because this is a 10, right? See, right? Yes. So this is a head and this will be the tail. So what we have to do? We have to display the complete nodes of this particular circular linked list. So in that, what we have to do? We have to start from head and we need to display each and every data up to tail. So what we have to display? We have to display this 10, 20, 30. So see, this is the data and this is the next. This is the data, this is the next. This is the data and this one is the next. So what we have to do, if we want to display this one, simply we can write it as head.data. Head.data, right? So how to move this one? How to move this head to this one, right? So simply we can use head is equal to head.next. So here, what is the head.next? Head.next is 2000. Now head is equal to 2000. Head is equal to 2000. That means the head will be pointing towards here. So one thing we should be careful, head should not be moved. Okay, head should be placed right to the first node. So that's why what we have to do? We have to take one temporary variable and store this head. So we can travel through each and individual nodes through this temporary variable. So instead of writing this one, simply print the temp.data. Okay, and up to where we have to travel? Up to tail. So how can we confirm this one? So simply temp.next is equal to, okay, simply self.head. So you can observe here, so head points 1000 and see temp.next is 1000. So then we have to stop because the last address of the last node will be having the first one. The last node will be having the address of first node. So the same thing, we are traveling this temp. We are traversing this temp from one node to another node and we have to repeat the same process. Okay, we have to repeat the same process until this condition. Okay, until this condition. That means, so temp.next not equal to self.head until this condition is true. So let us move on to the system. I'll execute the code. So for creation and display of circular linked list. So let's move on to the system.
Hello friends. So just now we have seen the theoretical part of circular linked list creation and display. So we'll write some code for this circular linked list, right? So circular linked list, particularly create and display. So in our further sessions we will see the next part. right? So first we need to create a class for node. So I'll create a class for node which will be having a two variables, that is a data and a next. So I'll use a constructor def init double underscore. The first parameter will be self and the second one is the data which we need to pass. So self dot data is equal to some data. So next similarly self dot next. So two fields, next will be none, initialized to none. Now create one more class for circular linked list, and here again initialize the two parameters. So one is head and tail. Okay, in order to travel from one node to last node, so we need to give some headings like self dot head is equal to none. Initially it will be initialized to none initially, right? So if there is no node, the head and tail will be none, right? So that's why I'm initializing this both of these with a none. Now write down the display function. So def display. So the one parameter is the default parameter will be the self, and here first one, if it is an empty list, automatically the head will be none. So if you want to create a linked list, automatically the head will be initialized and immediately the tail will be initialized. So if you create one node, so the same node will be pointing for head and tail, right? So here if the self dot head is none, that implies, so it's an empty circular linked list. So simply you can write here empty circular linked list, right? And else, that means if it is not none, so obviously that implies at least one node is available in the circular linked list. What we have to do, so we need to travel from first node to last node. So in order to travel from first node to last node, just initialize a temporary variable, because we should not move the head, right? The head should always point towards the first node and tail should always point towards the last node. So just take one more variable in order to travel from first node to the last node. So temp is equal to self dot head, so that here the temp will be pointing towards the first node itself. Now what we have to do, first print the data. So the data will be at temp.data. So in order to represent this one, I'll use arrows. Okay, there is no logic, just an arrow will be displayed here, right? And I will use a end parameter which will insert the node, which will display the next nodes on the same line. Okay, in order to avoid the multiple lines, so in order to print the output in the same line, I'm simply using the end, right? So now what we have to do, we have to travel from first node to last node. That means we need to move the temp from first node to the next node. So how we have to move that one? So where we have to stop? So where we have to stop means in the circular linked list, the last node will be holding the address of the first node. Last node means while temp.next. So we need to move the temp from one node to another node. So whenever the temp.next is not equal to, okay, actually if whenever the temp.next is equal to head value, because the last node address will be starting node, right? First node. So whenever this condition becomes true, we have to stop. Okay, whenever this condition means the temp.next is equal to self.head. If it is a single node, the head and the tail will be pointing towards the same thing, right? So here temp.next is equal to self.head means the node consists of the address of first node, right? So that's why we need to write the condition here. So until this condition becomes true, we need to travel, right? See, so that's why I'm using not equal to. So whenever these are not equal, then immediately the control will enter into the loop. Now simply travel, move this temp to temp.next. So immediately, initially the temp is holding pointing towards the first node. After executing of this one, the temp will be pointing towards the node which is available at the address present in the current node, right? That means next node. Now just print the data. We need to print the data, right? Print the data, again use the same representations, arrow mark, and print the same thing in the single line, right? After that, see, yes, this is the display. This is the display. So this will end whenever the temp.next value is head value, right? Now what we have to do, create one object for the circular linked list, because we need to call these things with the help of this object itself, right? With the help of this object only we need to call the things, right? So insert one node. Okay, I'm not using any function, directly I'm writing the code, right? So we'll see the insertion at the ending, insertion at the beginning in our next sessions, right? So here I will go with the n1 is equal to node of, I'll take 10, directly I'm taking a 10, right? So if you take this 10, if you consider this 10, what we have to do, we need to point, so one node will be inserted, right? One node will be inserted, and this node will be pointing for head and tail, because initially head and tail are none. If you insert one node, then simply L dot head will be n1 and L dot tail will be n1. So head and tail both are pointing towards the n1. And what about the next? That means the node address. What about the next address? So here L dot tail dot next will be right, self dot, sorry, L dot head, because if it is a single node, the address of the same node must be present in the address itself, right? So that's why L dot tail dot next, that means the address of this tail must be having the head. Then if you insert the second node, some n2 is equal to node of 20, right? So that means we are taking the second node. So I'm not writing any function, directly I'm using this one, right? So I have taken the second node. Now what we have to do, we have to change the tail. We need to change the tail, because the head will be pointing towards the starting one and tail will be pointing towards the second node. See, so here what we have done, we have created n1 is equal to node of 10. So that implies 10 will be here and here it is next. Okay, initially it is none. So here the head will be pointing towards this one, so it is n1, right? And the tail is pointing towards this one. Now what about this place? Initially it is none, but if it is a single linked list, what we have done, so last node should have the address of first node. So let us, the address of this node is 1000, so only one node itself here. So what we have to do, we have to place this 1000 in this next. So simply we can write it as tail dot next will be n1, or head dot next will be n1. So both the things are same. So you can write any one step, right? So because both are pointing towards a single node, right? Head dot next is equal to 1000. Automatically this none will be replaced with 1000, right? Now n2 is equal to node of 20, right? n2 is equal to node of 20. So what we have to do? So if it is a Yes. So node of 20 means again one more node will be created here, 20. So what we have to do, so node of 20 means 20 is created and here initially it is none. Now what we have to place, so in this position, right, in this position the address of this one will be, should be saved, right. So what is this position here, so tail dot next, so tail is pointing towards first node, right. So tail dot next is equal to, okay, this is n2, right, simply we can write it as n2. Now we need to move this tail towards this one because tail should point towards last node, right. So tail is equal to n2, so automatically the tail will be replaced here, that means it will be moved to the last node. Now what about this position, now the tail dot next should be address of first node. What is the address of first node? You should not use n1, right, head points towards the first node, right. So simply you can use head, right. So obviously a link will be created and the none will be replaced with 1000 and here the 1000 will be replaced with 2000 because this step replaces this 1000 with 2000 and this step will be changing the tail from first node to next node and this step will be placing the address of head at the end of the node, right. So hope you understood this concept. See, n2, if you create n2, so that's why we have written this one, tail dot next is equal to head. So this is a single node, so I'll execute this one. So we need to execute display function, so l dot display. So we have created one object, so l dot, this one is 10, and then if you create a one more node, so n2 is equal to node of 20. So what we have to do, so first we need to place the address of new node at the current node, right. So that's why what we have to do, so tail dot next is equal to some n2 and we need to move the tail is equal to n2 and tail dot next is equal to head. So here we need to call everything with the object because head and tail are the variables, right. So l dot head, l dot tail, right. So after the first node display, after the second node display, I'll show you this one. Sorry. See, after the first node, after second node. So just for understanding, right? After first node, and after the second node. So if you insert the third node, the same process, n3 is equal to node of 30, right. n3 is equal to node of 30. See, I'll erase all these things. Simply I'll write here so I'll write here the first node, second node, third node. So it is n3, n2, n1 and the address is 1000, 2000 and 3000 and the address of second node is presented here and here the address of the first node. So till now this is the address, this is the diagram. So this is a head and this will be the tail. Now if you insert n3 is equal to node of 30. So 30 is created, and initially it will be none. Okay, what we have to do, this 3000 should be placed in this position. This 3000 should be placed in this position because n3 is the node just after the n2. So what we have to do, the tail is pointing towards the last node. So simply repeat the same process. Tail.next is equal to n3. So tail.next means this one, this position. In this position, what we have to do, n3, the address of n3 should be placed. So 1000 will be replaced with 3000. Everything is fine. Now tail should be moved to this one. So whenever this address 3000 is stored here, a connection will be established. And now this tail should be moved here because n3 is the last node. So tail is equal to n3. So obviously this will be moved here, tail. Now here it is none. So this should be last node. This is a last node. So this should hold the address of first node. So again you can write the same thing, tail.next is equal to, what is the address of first node? So that is nothing but head. So head. So the same step we are repeating. The same steps we are repeating. So simply you can use the same steps. So just change this one n3, and this is also n3, and after third node. See, after first node, second node, third node. And in order to display the thing, so 10, 20, 30 are in the list. So last node is again 10, right? So here simply you can use, so here the temp.data is a 30, right? So simply you can write it here outside the loop. Whenever the condition becomes false, it comes out of the loop. So immediately we can simply write temp.next.data, so that, see, the first node and the last node. So that means the circle has been completed. So 10, 20, again 10. So 10 points to 20, 20 points to again 10. 10 points to 20, 20 points to 30, 30 again points to 10. Right? So this is a simple code for a circular linked list in order to create and display. So anything for particularly this particular data structures, if you draw this diagram and trace this one, simply the code will be very easy. Right? So hope you understood this one. So don't get confused. So in our next session, I will explain you about the insertion operation. So how can we insert a node? So the same code will be repeated, but we can use a function. Okay, insert function. So where we can insert? So what is the code we have to write if you want to insert the node at the beginning of the existing list or ending of the existing list? Right? So that we'll see in our next session. So let's stop here. I hope you understood this one, and if you are having any doubts regarding this today's session, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.